All right, everybody. Good morning. And we'll get this thing kicked off. First off, just like to thank everyone for taking the time out of their schedule to join us this morning. Just a couple of housekeeping items real quick. All attendees will have had their audio muted, so if you do have a question at any time during the presentation, please just use the Ask a Question button, which should be located at the top of your screen. Time permitting, we're going to try and answer as many of those questions during the session, but if we do run over time, we're trying to get this in an hour. So if we do run over time, we'll take any of those questions that we don't get answered offline and have them answered and get them back out to you guys right away. Also, for those of you that may have any colleagues that aren't able to attend this morning and may have had intention to, we are recording the webinar. So and we will be sending out a link to the recording to all attendees after we're done. So for those of you may not already know, my name is Ryan Tabor. I've been the systems engineer here at MBSI for about the past 10 years. Just kind of looking through the list real quick of some of the attendees already. I see quite a few familiar names, which is great. I know I've spoken to many of you either via the phone or email during my tenure here. For those of you whom I haven't had the opportunity to speak with, I do always enjoy engaging with clients. So please don't ever hesitate to reach out. The agenda for today is I'll be running through kind of a brief background of MBSI for those of you who maybe not be familiar with our company, and then a real quick introduction to Baicells before turning kind of the meat of the presentation over to Patrick from Baicells. We will have some time at the end of the presentation to review the Q&A, like I said. So again, if you have any questions during the presentation, please just use that Ask a Question button at the top of your screen. All right. So who is MBSI WAV? So MBSI WAV is a Canadian company. We were formed through a partnership with WAV Incorporated, who is out of the U.S., and MBSI Canada was a partner here in Canada. The mission of MBSI WAV is to be Canada's premier value-added distributor of both wireless and networking technologies. We attempt to kind of provide these with dedication to the highest quality customer experience and unrivaled service and support. We believe we provide really good product knowledge, support for multi-vendor solutions, as well as professional value-added services, including staging, configuration, path profiles, analysis, and site kitting. We do have some unique channel offerings, we feel. We have a really large stocking position of wireless equipment in Canada, both in Alberta and in Ontario. We offer a price match guarantee, just-in-time shipments, ability to blind ship to customers, which we do quite often, or end customers, and the ability to offer end-to-end wired and wireless solutions. Some of our value adds, we're a one-stop distributor. We have a wide breadth of wireless broadband, both indoor and outdoor wireless products. We have really unrivaled customer service and responsiveness. I believe those of you that have been dealing with us for a number of years can vouch for that. We're pretty responsive when it comes to emails or phone calls. Staging, configuration, pre-installation, hardware kitting, we do all that. And of course, wireless broadband design services, whether it's indoor, outdoor, WLAN, point-to-multipoint, point-to-point, licensed, unlicensed, whatever it may be. Here's a kind of a quick, quick slide here, just on a few of the vendors we do deal with today. Both in licensed, unlicensed, point-to-multipoint, point-to-point, and then over accessories, WLAN, switches, everything. So that kind of brings us to this slide here, Baicells. So for those of you who are not familiar with Baicells, they are a high-tech company dedicated in wireless broadband access solutions. Their main product portfolio and solutions cover rural wireless broadband, indoor and outdoor small cells, CPE, antenna, and everything under the sun. So with their vision to connect the unconnected, Baicells has introduced some real breakthrough technologies to the LTE system today. Like moving a complete LTE system to unlicensed spectrum and building it with an IT and cloud-based architecture. With Baicells' turnkey end-to-end solution, it becomes much easier provide wireless internet without everyone's reach at a very low cost. So I think that's really key. Is the cost per CP and the cost per end user is much lower than some of the competitors that are out there today. Baicells' innovative solutions can be used by mobile operators, broadband access operators, cable operators, mobile virtual operators, governments, enterprise, just really a wide breadth of applications out there. So for those of you, might be thinking, why LTE? Baicells, is offering LTE at a value that puts really, puts the myth to rest that, LTE is just too expensive, specifically for wireless ISPs and smaller operators. Small towns, government, cities, even verticals, like oil and gas and, municipalities and so on and so forth, utilities, that might be interested in LTE for private networks. So why even look at LTE? Well, and this kind of leads into Patrick's presentation here, but really, we feel it addresses really two simple issues. So, some of the challenges with non-line of sight that many operators are dealing with today, and then of course the benefit of using a solution developed with a standards base, and that's one big differentiator is that they are interoperable with even other LTE solutions that are in the marketplace today. So I'm just going to turn it over to Patrick, so you can get into the meat of the presentation and why everybody's here. And bear with us, we have had a few problems with this application, getting Patrick's screen to show. So we'll give it a try here, see what happens.
Let me know when you see it, Ryan.
Okay. Yep, there it is.
Well, there we go. So, Ryan, thank you very much for the introduction. I feel your pain with having to read a full slide of gobbledygook about the company, marketing speak. That's always got to be unpleasant and awkward.
Got to be in there.
So.
Yep.
Right.
Hey, no worries.
So
no worries.
Thank you, everyone, for joining. We really appreciate it. Slight disadvantage, I don't get to see who's on the call. So if I don't know you, it's nice to meet you. If I do know you, well, it's good to be speaking with you again. There is an applet, a Java applet that runs in the background here, or in this case in the foreground. I apologize. I don't have the option today to minimize this little guy, so he's going to sit in the way and accompany us as we go through this presentation. So I'll try to keep this as layman as possible, partly because I'm not really a technical guy, although I can play one on TV if I need to. But what we're doing actually is relatively simple here at Baicells. So I'll try to cover that. See, we've already gone through 3 slides. Before I do, one of the things I always like to discuss, and I say that because this guy was probably the principal reason why I joined this company and decided to leave my former one. So why are we a credible voice or even a credible organization as it relates to LTE, right? So the LTE standard is, there's hundreds of companies involved. There's over $1 billion in R&D going towards it every year. The stack of standards is hundreds and hundreds and hundreds of pages. So what qualifies us, other than being a manufacturing and low-cost Asia, as being someone worth maybe talking to or having a voice that you should even respect, frankly. So this guy is a big reason of that. So the company was founded by a gentleman called Mr. Soon Lixin, or as I originally called him on my first video chat with him, Lixin, which was really ignorant of me, but he laughed at me rather hysterically, and I thought, gosh, he's a cheerful fellow. He was just too polite to let me know that I was butchering his name. So I just call him Mr. Soon to keep it easy now. But he was one of the 12 fellows at Huawei, and there are 12 of those, but they're the top guys at the company, or at least top leaders. And he was responsible for building the IPR over there, and even pre-Huawei, he's the guy credited with building the in-country IPR in cellular. So prior to really his building a practice in a team and intellectual property internally, they were bringing in all the experts from Nokia and Ericsson and stuff like that in country. So he's pretty well revered over there from that standpoint. And over the course of his term with Huawei, he took on positions leading their regulatory and spectrum and IPR teams, and that led him to chairing many of the Pan-Asian 3GPP and ITU sub-organizations that are driving the LTE standard globally. So he got to meet pretty much the top scientists in engineering minds in IT and telecom revolving around the mobility space, which has given him a lot of street cred in there. But he left Huawei at 44, 1 year before he could have enjoyed full retirement, which would have been a very, very, very large amount of money annually. And he walked away from that, even though he didn't have to. He could have stayed 1 more year and then walked. But he didn't think that you could basically turn a battleship in a bathtub. And he has a much broader vision for LTE than the big giant telecom companies. And I share this vision, and that's basically the idea that LTE is finally going to be the technology vehicle that allows IT to eat telecom. So telecom has always kind of been a proprietary, a complex, and a very expensive infrastructure and architecture for communications. And he really believes that LTE is the linchpin that will change all that for a number of different reasons. So he founded this company. One of his mottos is easy as Wi-Fi, and that's one of the things we're driving towards. But he's kind of like a Silicon Valley guy, and he works out of a cubicle just like everyone else, and apparently that's not very Chinese, but that's very Mr. Soon. So pretty laid-back guy, but he's working harder than anyone else, and he's been great to work with. So that's there on the kind of the macro global level of credibility in LTE. The nut of that being that some of the key inventors behind LTE in the first place, we have resident on our staff, which I think is pretty powerful stuff. In terms of the fixed wireless space, I certainly am not an LTE expert, but as it relates to fixed wireless, God knows I've been around a long time, since I'm technically around 1996 is when I first got into it. And so I was pretty much there when the very first wireless ISPs were coming online, whether that was Midcoast in Maine and some other areas. I've been around the space, seems like forever. I've done a lot of work with the SEC in particular, but also some with the IC in helping to influence some spectrum decisions to the extent that I could. And any event, so from a market standpoint, that's something I get. But there's always been a considerable gap, I thought, in the vendors I've served under before. And that's that there was no one on the staff, no matter how expert we were in the technology, in the case of Mr. Soon, or how expert we were in the market, in the case of, frankly, me, no vendor I've ever worked for had an expert that's lived in your shoes from the operator standpoint. Always thought that was a gap, and that's always something I told myself, if I ever have the opportunity to lead a company, I would rectify in this space. So my first hiring decision was to try to influence Rick Harnish to come on board. For those of you who don't know him, Rick was one of the charter founders of WISPA, and not only that, he became its first executive director and led that organization from over 100 companies to over 800 member service providers. In addition to that, Rick was just like many of you, assuming that I'm speaking to service providers. He was a farmer, a guy that lived in the rural community where he discovered there were major gaps in, in the quote-unquote broadband divide thing. So he built a company and built it up to over 3,000 subscribers, and which is a pretty stunning achievement, circa 2005, and sold that off, and then focused on building WISPA. So this is a guy that's lived intimately the daily lives that you guys live as service providers, in particular rural service providers. So that was a key decision, I think, on my part. So we never lost sight, and we always had an advocate internally who has literally walked in your shoes. So more about the company in particular. We've been around since 2014, early 2014, approximately May. So we're not even 3 years in. However, at this point, we've got over 250 patents and patents pending. And if you're able to see the screen there on the right, or the graphic on the right, you can see it covers a really wide range of stuff. Frankly, my challenge is keeping everyone focused on building just specifically the products we need. There's a very large skunk works mentality that goes on back in the R&D side, and they're also always dabbling in these very interesting, occasionally obscure, but some potentially very large kinds of opportunities, from virtual reality, LTE on drones, and a number of other things. But point being here is that with our 250 or so employees, a huge percentage of them are involved in R&D, covering the whole gamut of sub-disciplines within RF. I think part of that, the expertise is partly so high because people wanted to follow Mr. Soon. So he attracted a lot of people from Huawei and China Ericsson and others to come join him, and he's built up specific practices in all these little various groups. With the exception of antenna, we have shed that group for now because there's plenty of good third-party stuff up there. So I actually have to fix that in the introduction. But in any event, building up a very strong IPR portfolio. And because of his reputation, we've already got projects going with Facebook, with Google. We have specific engagement with Intel. For example, we are one of the few companies Intel has given full source code access to their LTE chipset, principally for small cell, which is a huge, I think, statement of trust on their part. Additionally, Intel's even paid us a couple $100,000 to develop some prototypes for some other markets that they're working on. So we've got our fingers in all kinds of pies. But here in North America, we have to provide the revenue from the basic level. So we're serving currently the fixed wireless space and also leading into the small cell space. This is kind of what we look like right now. This graphic needs to be adjusted, but there's currently about 150 customers globally. Not a huge number, but considering that in North America we've only been shipping products since about October. I think, Ryan, you may not know, but I don't think MBSI WAV got their first hunk of gear pallet from us until I think it was probably late October. But
yeah, that's about right. Yep.
Yeah, we trialed in North America for a couple of months, including customers in Canada, with about 60 customers. Actually, technically 62. Only one customer sent gear back, and he sent it back unopened in the box because he just decided they didn't have the bandwidth for testing. But interesting in that particular equation is that we didn't have to send an engineer to a single site, which gives you an idea of how simple the product set is, and we'll talk a little bit about that. But in any event, so we trialed with about 60 customers. That trial went through pretty much October. Some still consider in that stage, but in any event, since then, we've grown by about 2.5 times in terms of customer count. So just in the last part of this last quarter. So the growth has been pretty rapid, and we're very encouraged by that. So, okay, I think you've all probably heard the story of LTE as a standard. Okay, yeah, I should make a couple points about that. We're all carrying around in our pockets, in our purses, and whether we fully pay attention to the fact that's LTE or not, it is. And it's been pretty amazingly successful. But what's only begun to recently happen is that because of the adoption of LTE to such a scale on the mobile side, where all the different old mobile technologies are collapsing under this unified standard, the gravitational weight of that and of the spectrum environments and of the nature of the workforce and people moving around and the apps of streaming and everything else, means that LTE, the influence of that standard, is finding its way into other environments, to include the fixed market. And frankly, you'll even come to realize in the next couple of years, even in terms of Wi-Fi replacement, although that's another story I won't get in here. But it's making its way into the fixed market for a lot of good reasons. There are elements of the standard specific to that, finally, but it's just a great technology for fixed wireless. What's been the big problem of fixed wireless all these years that we've all been serving in it? And that is, unless you've got a fair bit of low band, higher power, licensed band products, whether that's 3.5 or 2.5 or something, you've always been challenged with the trees. So it's already a standard adopted with mobile, now moving into fixed. You're also going to see it in Internet of Things. There's a narrowband LTE standard that was ratified in June, in particular 900 megahertz narrowband. So LTE is finding its way really into the sum total of the communications, wireless communications marketplace, not just connecting people, but now homes and businesses and eventually things. So that's all well and good, and it means that economies of scale will drive costs down and availability of devices, all that kind of good stuff. But again, as a wireless internet service provider, that all sounds nice and important, and maybe it makes the value of your network to investors ultimately higher. But at the end of the day, you've got to serve your customers. And many of you are using products in 5 gig, especially up there in the Great White North, where you have very high tree density in a lot of places, where if you're sitting on a tower, currently you may be only able to access, 20, 30% of the potential customer set within your sites, simply because of foliation. And in the 5 gig technologies as they are these days, there's a couple branches in the way. That may be it. That may be enough to really deter giving that customer a reliable link. And sure, you've got options like old legacy 900 and everything, but the bandwidth requirements of the customers today, you can no longer really deliver and scale the kind of capacity needed. So how does LTE enable a better non-line of sight connection? So this is a question we get all the time, and everyone thinks there's some degree of magic. It's not. It's really just basically simple math. And this is not a vendor issue. So this isn't a Baicells issue. This is an LTE issue. On a per modulation basis, LTE has a much higher level sensitivity than your basic proprietary or Wi-Fi derived product. For example, there's a good chance most of you aren't connecting any customers, let's say, worse than about a -70 RSSI. So I'm guessing it's somewhere in there, maybe a -72. Well, in LTE, you're still at the very southern edge of QAM 64 at -83.5. So that's a substantial difference in terms of sensitivity. And that really is the kind of the simplest way to explain why LTE does such a much better job in non-line of sight. So in the real world, as you're thinking about it, how does that translate? Because everyone's version of non-line of sight is a little different. That's especially true down here in the lower 48, where in Texas you've got cottonwoods. In South Georgia, you've got tall pines. You've got sequoias out west and thick deciduous trees in the Midwest and things like that. Well, the best I can explain to people, if you're familiar with using 900, which I assume many of you are, whatever you could connect in 900, I'd say you have probably at least an 80% shot of connecting it with 1 watt, 3.65 LTE. But at maybe 10, 15, 20, and even 40 times the bandwidth. And I mean that literally, 40 times the bandwidth. I've got ample examples of 900 replacement and 2.4 replacement, frankly, achieving 20 and 40 times improved throughput. So that's a huge deal, and that's why I have this picture up here, for example, on the right, where most of you probably in a 5 gig aren't going to install a link like that to a tower that's, maybe 2-3 miles away, simply because the trees near into that subscriber would prohibit that connection in normal terms. I'm often asked,
Patrick, if I could just intervene for a sec, I think it's really kind of important to really reiterate that point. I get this question all the time, and what is LTE isn't magic, and just like you put it, right? I mean, physics are physics, and how RF propagates is no different, with LTE versus say any other type of product out there. But it's just really important to know. I mean, yeah, exactly. The receive sensitivity at those specific modulations is considerably lower, and that's why you can get the capacity. You're not going to see you should not see a better received signal level or something like that versus maybe an alternate or maybe a competing product using a different technology. But again, just the receive sensitivity at some of those lower modulations is that much better, so it allows that allows those radios to modulate up and get the capacity that you need.
So you're not just the marketing guy. Okay, good. Yes, that's absolutely true, but it is really the salient difference, and I'm quick to correct people. I think I'm fairly well known for being a pretty blunt speaker. God help me that sometimes that works against me. But the last thing I want people thinking is that vendors are doing some sort of tricky black magic crap. That's just not the case. It's just the nature of LTE, and then you get the benefits of all the R&D behind it and the global standards and yada yada yada. But it's really the non-line of sight that's really the big deal that's frankly driving our business. In fact, that presents a problem for me, right? So the fact is every one of my customers is still using another technology for line of sight. So on the product set, that's something I'm working to resolve. So frankly, I can get a larger share of your CapEx dollars. But most importantly, I want you to do the things that are in the interest of your business. So if that means you use someone else for your line of sight, great. But we're here at least right now to solve your non-line of sight problems. One of the questions we get is, okay, so what kind of speeds can realistically be delivered? So this would be an example of an optimal link, right? So we're about 110 megabits in terms of gross available throughput. So great, what does that mean in real terms? Well, here's an example of what that can mean in real terms. Now, this is the best connection I've seen, but it's sent to us from a real customer. So that gives you the really north edge of what's possible. Obviously, that's the top modulation. This is probably a line of sight sort of connection. All the same rules apply, folks. So, when you're even, as you're doing non-line of sight connections, you can get pretty giddy when you think, oh my gosh, I couldn't connect this guy at 900 and now I'm getting 30 megs. Holy cow. Yeah, that's nice and everything, but you still got to mate to the realities of physics, as Ryan implied. So you still want to try to keep people connected, at least in a high QAM 16 modulation, so you're preserving capacity on your base station, right? Because the net capacity on any sector is defined by the average speed of all the users. So if you've got guys driving through 3 miles of trees getting marginal connections, even in LTE, although you may perform a little bit better because of scheduling and things like this, and your ability and not having the near far problem that you traditionally have in Wi-Fi, you're still taking a major hit on overall capacity. So please pay attention as you do this to even trying to optimize a connection that you already think is stunning. Do the proper best practices and move that antenna around until you get the maximum signal. So, okay, so what kind of products do we have? Well, right now, certified both FCC and IC are a handful of them. There's a lot more coming. but let's describe them. So we have 1 watt products in the 3.x realm, and when I say 3.x, the operational parameters technically would run from about 3.5 through 3.7. We try to keep the filters relatively narrow, but we want it wide enough to be able to include the future US CBRS band, which is 355 to 37. And that's a 1 watt product. There's multiple CPE certified under that. Actually, we have 3. So one of them we have is a 19.5 dBi panel, which is this guy over here. And that's the highest gain panel offered by any vendor in the marketplace for LTE. And that's one of the other reasons we maybe do a little bit better than some other guys on our non-line of sight, even on an LTE standpoint. In addition, we have this guy. This is an 11. So why would we have an 11? Good question, because when my guys were helping define product and they said, okay, this is the CPE we have this 11, I was like, wait a minute, I want a higher gain, that's not enough. So I convinced them to design and go with this higher gain. But then as it turns out, we just randomly had a couple operators in our trial testing this little guy here. And much to our surprise, that 11 dBi lower priced CPE performed better in many cases in very short range non-line of sight, especially where trees were near to the subscriber problem. And the reason we think this is a wider beam antenna, right? This is 19.5 over here, so it's something like a 22 by 22 degrees. As an 11, this is a much wider beam. It's more like 90, which frankly kind of I'm uncomfortable with because it sends a lot of signal in places you maybe don't want. But if you're keeping it kind of near into the tower and you do have very challenging non-line of sight issues, this can help, I think, because the wider beam is apparently collecting more of the reflections off the foliation. And one of the other things that LTE does better than Wi-Fi is that the processing power of LTE is a fair bit more sophisticated. So it's able to basically take all those reflections and form that back into a coherent signal. So even though this is less expensive, for some of your shorter range cells, this may actually be a better solution. Then we have this indoor guy, and why the heck would you have an indoor CPE and low power 3.65? That's especially true in the US because the FCC for us, they don't define indoor or outdoor, they define fixed or mobile. And they consider this a mobile device even if you bolted it down on your desk. So because of that, the rules down south are that the power of this device is frankly choked about 1/10 of what these guys are. So why the heck would we certify it anyway? Well, our base stations are priced so inexpensively relative to anyone else in the LTE market that we're discovering that people are putting our base stations out on even the remote edge of a network where you just can't make the dollars work on a much more expensive base station. On ours, they're relatively low price, but even maybe 10 or 15 customers on a base station, maybe provided they're slightly high ARPU customers, you can actually justify that in the business model. And because of that, we found people are doing microcells, whether that's kind of a low in the pole sort of deployment. In that case, you're maybe only trying to get half a kilometer or something like that. And it turns out these CPE are really good in that environment. So let's say you're doing, you're in a First Nations community, some were kind of remote, and the preponderance of the residential or commercial density is a little nucleus of a town. This could be a really good solution, especially if you don't want to deal with maybe the harshness of putting something outside. College campus, traditional apartment complex, light high density, light industrial office complex, something like this. So we decided to certify it, and it's kind of a boutique product. We're selling a limited number, but it's just another option, just another tool in your toolkit that we wanted to provide because no one else had a solution like that. So, okay, what are these guys attached to? There's the 1 watt base station. There's also a 10 watt. I'm a little cautious on this guy because the current one is in testing, and I think there's a little bit of refinement that needs to go. So what's happening is that the 3.5 gigahertz 10 watt product that's coming out, it'll be a slightly different form factor. It'll have an SFP cage on it, be slightly more advanced. But MBSI WAV in particular has put in an order for that, and some of you guys on here are waiting for that, and that's actually that's not that far off. We just wanted them to do it a little bit differently than they had executed the 2.5 gigahertz 1 watt product. So they're making the modifications for that, so it's a better product. But in any event, there's those two base stations. Additionally, there's a couple other things that are coming out in the very near term. We have small cell products. They're not really relevant yet to North America, but it's important if you are playing in that space. We are becoming a significant player. For example, we've won 24% of China Mobile's small cell business, and that's the largest cellular provider by subscribers in the world. That's something to the degree of hundreds of thousands of small cells over the course of just this year. We're even integrating them inside of exit signs in buildings, for example. But one of the other products we were coming out with is this guy. I just got back from China and convinced them to take this back into production. They had prototypes developed, but they didn't think there was a market for it. We've convinced them otherwise. What this is actually a 2x250 milliwatt base station with an integrated 90-degree antenna that has PoE. This is 48 volt power, but this little guy is going to be really good for the low and the pole sort of solution. It's going to be very, very low cost. I think that the intended list price US is somewhere south of a fair bit south of $3,000 list price for this guy. Again, comes with the antenna, and the idea is that this will be mated with maybe this CPE or this CPE in kind of tight microcells. So the other idea is that when you have precious spectrum, whether you're, especially if you're doing 365 or whatever it is, and you're really trying to preserve your channels, the idea we think is that you could, instead of ABAB, you can do that on your macro towers, but that we think with this lower power base station, you could actually have these little smaller cells under the macro umbrella that can be, if they're engineered properly, that won't interfere with the larger cells. So if you have these down low in a pole and then have have CPE short range communicating back to this, you may actually be able to reuse your spectrum more effectively to capture a little bit more density, or simply put these on the edge for a very low cost method of attracting subscribers. So that's one thing that's coming. I hope we have this somewhere inside of about a quarter and a half. Additionally, I don't have pictures here, but this is new news that I can officially share here, is that there will be a 2 watt product, which is highly unusual. It's going to use a special chipset, kind of a state-of-the-art chipset due to some of our relationships that we've got in the chipset space. And that's going to be a very interesting product because it'll slot between 1 watt and 10 watt, should be priced incredibly competitively, and it should be able to, there'll be 3.x versions of those. So in the rural Canadian marketplace, as your rules allow, where you can do much higher power, you'll be able to access the higher power with that particular product without having to go to a 10 watt product. Additionally,
yeah, Patrick, up in Canada anyway, like the certain areas, I mean, most of the time it's 1 watt per megahertz, which, like even the 1 watt base station can support. But I mean, there is like those, real low populated areas is how they classify them up here,
right.
that, can be allowed up to 60 watts per megahertz. And I mean, there's not a lot
Right.
of those areas, but I mean, some, definitely deployments fall into those. And obviously having that access to that higher power at the base station is definitely important, for sure.
Yeah, of course, sometimes higher power isn't always better, but it certainly helps when the density is really low. But we just, we wanted to present the option, just like we have on the different kinds of CPEs. We think it makes sense to finally give people much more options on the base station. So we're trying to be creative and not just do 1 watt and 10 watt, trying to offer something in the middle there, like a 2. Looking kind of more broadly across the scope of all our products, this one, not sure though will activate this guy, but this is a product in test. It's not really relevant to this market. It's just another small cell, and this is a tiny cell called the ELF cell, roughly the size of an iPhone. Give you an idea of the kind of progress we're making is that last year in Barcelona in Mobile Wireless Congress, this little guy was under glass in both Intel and Qualcomm's booth, which at that week is some of the most expensive real estate on the planet, is a booth of one of those major companies in Barcelona. So the fact that in the center of their booth was sitting this stuff from humble old little Baicells gives you a little bit of an idea of just how innovative even those big guns really think we are. So we are doing some creative things and coming up with some very interesting options. We also are co-chair of this group called the Multi-Fire Alliance. What the heck is that? So Multi-Fire Alliance is a group that's formed to, on the market side, help commercialize the new standard that basically takes license-assisted access, or LTE, in the LAA methodology. It uses a combination of licensed and unlicensed spectrum, all using LTE. What Multi-Fire does is it sheds the license side of that and says, you know what? We're going to optimize the LTE standard and help commercialize it for the market in purely unlicensed bands. And to do that, they have to add certain capabilities like an LTE version of a listen before talk, kind of like Wi-Fi, so you have some better interference resilience. So we co-chair that particular alliance, and one of the outputs of that particular effort later this year will be a dual 3.x, 5.x product in a single box, which should be very interesting, with some very interesting capabilities. So right now that's vaporware, but I'll lay it out there to let you know that some of the exciting stuff that's being worked on. We've covered these guys. These are, this is an IP67. This is an IP64 in terms of environmental protection. And for those that don't know, the first number refers to ingress of solid particulate matter, 6 being dust-proof. And the second number deals with the ingress of moisture or liquid. In the case of a 7, that means basically watertight up to about 1 meter for 30 minutes. And whereas a IP65, the 5 implies jet spray, a jet sort of force of water. So, for example, anyone not really translating that in the real world, your legacy, the original canopy stuff, was an IP65, and there are still plenty of those out there. So 67 is just a slightly tighter environmental standard, and these are 65s. This is probably a 54, which is, since this is an indoor model. But in any event, pricing, they go up from lower to high here. But even on the high scale, this guy from a U.S. standpoint is only a list price of $225. So, fairly reasonable on that front. So this part, this is important. So how do we do the EPC? You know, one of the things that's made LTE so ungodly expensive is the fact that you have to have this thing called the core, the enhanced packet core. It's a fundamental element of the standard. You don't have it, you're not standard. You're not standard, you can't play, you can't interoperate. You ain't LTE if you're not standard. You can try to pretend you are, you can do all kinds of marketing crap to make people believe you are, but if there is no core, you are not standard, and that means you probably can't use anyone else's CPE or mix and match, whatever it is. We want to make sure that our customers have the flexibility that if our stuff doesn't meet your standards for CPE or whatever, that you have the opportunity to mix and match. So we're really adhering to standards. In our core implementation, traditionally what most companies have done is they provide an appliance, which then is either centralized or distributed in some manner. We lead with a cloud solution using Microsoft Azure Cloud. We have multiple servers now in North America for redundancy. But not only do we put the cloud up there, we put our management console, our OMC up there, and also the what we call the BOSS, which is the console for managing the CPE environment. Everything is up there in the cloud in using Microsoft Azure servers. Nothing leaves North America, so you have that level of security as well. But it's been pretty good, especially as we add redundancy using multiple Azure servers. But the power of this in the cloud is something that some of the bigger guys are driving towards anyway, and we're just kind of getting there early. One of the benefits is it kind of separates the control plane from the data plane a little bit, so you don't have to have the super high-end Ciclu or Ceragon backhauls necessarily. You can run successfully with our gear even with a lower-end backhaul. But because we use the cloud, we have no upfront cost for an EPC, zero, as in zero. Ultimately, and I say ultimately because it's not even, we're not charging for it yet, ultimately it'll be a $1 per month per subscriber, which is a really simple pay-as-you-go. And then if you scale up to a certain point where that seems a burdensome fee, then we'll provide an option of having a local EPC. So that's another way that we're really trying to bend the existing price paradigm that's kept LTE out of the hands of some of the people who need it most, which is the people I assume are on the other end of this call. So we're very simple. Part numbers, you've got base stations, you've got CPE, and that's almost it. When we ship our base station, it comes with a GPS unit that is not an additional line item. So the only thing you have to buy is base station, CPE on the other side, and your 48-volt power cabling, and an antenna. Literally it. Comes with everything else. So it's a very simple order. And how do you operate this stuff? It's as easy as Wi-Fi, which is the model. Something I didn't believe in the beginning could ever be possible given my previous experience. As I said, we didn't have to ship a single engineer to any of our test sites because the easiest Wi-Fi part turned out to be true. So when you get a base station, the first thing you do is you get the SIM cards activated. The second thing you do is you plug in the Ethernet ports into active internet connection, and then you power it up. It instantly acquires its connection in the cloud, and you can literally begin servicing that right then. Now, there are things you can do to optimize or adjust. For example, the defaults, what they call subframe assignments, provides a certain TDD ratio that gives you X downlink and X uplink. Some people may want to tweak that to lower their downlink and have a little bit more uplink. But the salient point is, once your SIM card is activated, it is literally plug and play, which if anyone's dealt with other versions of LTE, that's rather astonishing, and it's something we're pretty proud of. Interoperability, this is important to us, and to put some meat in the bone to kind of prove the point is we've won a lot of business with China Mobile, and just like AT&T and Verizon, they've got a ridiculously arduous process to prove out the gear. So we've gone through that rigorous testing in China Mobile's environment with at least these different other eNodeBs and cores and UEs, meaning CPE-like devices. The rest just kind of pretty diagrams. That's pretty much it, and we have a little bit of time for Q&A, I think. So let's get to that if we don't mind.
Okay, sure. One thing I'm going to mention too, we talked about, really, what products you need to get this working, and you mentioned the antenna. I mean, yeah, like Baicells does not sell an antenna, and it's one thing that's, I find it's, definitely overlooked. I mean, we're talking about deploying these solutions into a lightly licensed, into 365, which is lightly licensed. There's still definitely a big possibility of interference from an incumbent, or of course, the worst, would be self-interference. So, the best way you can mitigate that, especially on this, as far as self-interference goes, I mean, GPS sync and stuff like that is great, but it's also not enough. It's really important, and I need to, just put this point home. They're really important to have a good quality antenna with a good front-to-back ratio. Anything you can do to obviously limit the amount of interference that you're generating on your own, especially if you're, putting sectors back to back and things like that, that will help definitely on the uplink side at the base station. So, whenever you're looking at antennas, make sure, again, front to back is very important, and good quality antennas.
No, that's you're absolutely right, Ryan. In fact, narrow too, also narrow antennas. Some newer service providers think you need to go 360. You need 490s or two 180s or whatever. RF doesn't really work like that. So in this space, a good 65-degree antenna, 3 of those can even get you up to close to 360. Certainly 4. So
for sure, there's some roll off as you get to the edges, of course. But I mean,
right.
Again, that really helps that to mitigate that self interference at the tower site, and which will generate with any product, right? I mean, yeah.
As well as maximizing your power density. So yes, that is true. Antenna selection is key.
Great.
I would also say, if anyone's curious of learning a lot more, we have a very active Facebook closed group called Baicells Operators. There's about close to 500 people in there. Some people very active, posting pictures of results, non-monocyte pictures. We let the dirty laundry hang out there as well as the good stuff, and everyone finds out the dirty laundry anyway because this is a small community, so we don't hide it. Everyone has problems. It's how a company responds to it. So we give people the opportunity to see how they respond to challenges. So we do a lot of very active customer engagement, very active, including regular Friday updates, all the Facebook stuff we do in a number of other formats. We also have a community forum. So I would encourage you, if you haven't gone there, go to the Baicells Operators page and invite yourself in, and we'll get you in there. But if there are any questions, let's take those.
All right. Yeah, anybody on the call, if you have any questions, feel free to ask them now. First question we have here is, what is Baicells standing with the Communications Security Establishment's Security Review Program?
Very, very good question, and I am absolutely appreciative you asked that. So one of the first things I did, realizing the reality of that challenge, in particular in Canada, where CSEC is a little bit more sticky about that stuff than even our boys down here, is I personally reached out to that organization in Ottawa to introduce ourselves to them, right? So over many, many months in trying to organize schedules, Doris Landeville, who is one of the leads for that particular program, she sent 2 of her people down to one of our offices, the office in Madison, and we met with them. And we went through all our products, what we're doing, how we do things in the cloud. And 1, they were very impressed. 2, they were very appreciative that we had taken the effort to be proactive with them. They'll pat on my back for that one, for knowing the space well enough to know that could be a potential big problem. But we also wanted to convince them that, listen, being primarily fixed-based, we're not a threat. So they agreed that we're all good to go at this point. There's no barriers to using our gear. What they did ask us, and what we did offer, is that as we achieve certain milestones, we'll let them know. And when we introduce new products, we'll let them know. Principally, what they were most concerned about was, for example, let's say we were doing a big project where we were doing an LTE IoT product, or say someone like Hydro One, some big power company. As critical infrastructure, they would consider that verboten. That would scare the crap out of them. And they want to know that sort of thing. But for what we're doing, bridging the divide in rural areas and stuff like that, they were all about it. So I couldn't have been happier with the outcome. I was nervous about it. I wanted to confront it head on first thing. We did that, and I think we kicked butt, and we came away, I think, with a lot of mutual respect. I was very impressed with their group. The people that they sent down were incredibly sharp, understood, and hey, so that's it. We're good to go on that front right now.
Okay, great. Another question here, does the Baicells solution future-proof us for the 50 by 10 mandate that's coming, and if so, at what distances? I think what this is in relation to is the CRT submission on Canada. Yeah, so. Yeah,
I do understand. So 50 by 10 is possible. Is it possible to do that in scale under this version of LTE? Okay, that's tough. So I think you can meet the mandate on a on a technical level. In practical terms, being able to scale with those kinds of subscriber sets becomes more challenging. I think maybe you can get some 20 subscribers potentially doing that kind of throughput, assuming you're connecting in the higher order modulations, right? So that's one of those things. I can't answer that for you. If you have shoddy connections, what can I do? You know what I mean? So if you're in the high order modulations, yeah, I mean, it's absolutely possible to connect, say, maybe 15, 20, maybe 25 customers, potentially doing like a 50 meg service, 50 meg, close to 10 up, or on the edge of that, depending on your subframe assignment. So yeah, sure. Technically you can.
Yeah, a lot depends on things like oversubscription ratio, and a really good point on really link budget. Link budget quality is back to the CPE. I mean, if a lot of your connections are very weak, obviously, the LTE base station, like any other wireless, is a shared resource, right? So, those connections, I mean, the amount of time that base station has to spend, providing the same amount of bandwidth to those connections in a lower modulation means there's less resources available at the base station level for, obviously, for bandwidth to other subs. I mean, everything really is treated as best effort unless you're using, some sort of quality of service, for maybe VoIP or video or something like that. But other than that, I mean, yeah, good point. I mean, those link budgets, still are, mean a lot, so.
Yeah, and realistically though, because of the price points of our gear, we are finding people even using Omnis. Now, everyone knows all the caveats, and we're like, oh my God, an Omni. But hey, you know what? If you only got a few people at the edge, or you're someplace close nearby, there's nothing around, and that's what you need to do to get service out there economically, by God, go for it.
Sure.
As long as you understand the consequences. In those situations, though, there may be only connecting 10, 15 customers, so it's not quite as important to have super high order modulation, but can I get you 50, 10 in that environment? Maybe not.
Yeah, exactly. Yeah, putting an Omni, not only is it difficult to, mitigate, interference, like, in an environment, especially with 365. Yeah, licensed spectrum, then, but, in 365, which, majority of, deployments would be in, that's obviously one of the big caveats. And then second, of course, is just, a lot lower, poor link budget, difficult to mitigate interference is like the biggest one. But, omnidirectionals for sure. 100% supported, but there's definitely some things to consider when you're looking at that. So another question here, how many VLANs are needed for deployment, and what are they? Example, data, infrastructure, layer 2 at layer 3. I think we're probably talking about management, and then at the payload level, I mean, I believe, I mean, you could, check me if I'm wrong, but I mean, the solution can be deployed at layer 2 or at layer 3, correct? And have multiple VLANs. It's going to support, tagged frames, untagged frames. It really doesn't care on the Ethernet side, I don't believe. But,
well, yeah, it should be clear. So, and as we get deeper in that kind of stuff, I become less and less expert. But it's important to note that layer 2 is not native in LTE. It doesn't exist, period. So those of us vendors who are optimizing for the fixed space have the burden of coming up with a layer implementation, layer 2 implementation that works, right? So ours, for example, is not 100% baked, but is expected to be done by the end of this month. We've actually entered testing on this tomorrow with a set of first 5 customers. We'll run it for 2 weeks and then open up to 20, then run it for another week, and then open up to everyone. One of the problems of adding layer 2 into LTE is that most implementations come with a capacity hit that's somewhat significant. So we worked hard with lots of different scenarios, and we've come up with a way of doing it that has enabled us to apply for a patent. So we have a patent pending implementation of layer 2 that is going to be very simple, flexible, and will have minimal capacity hits. But I just wanted to lay that out there because I don't want anyone to misunderstand that this is just like a regular Wi-Fi product where you've got bridging and all that kind of stuff native. It's not in there. It has to be added. So the specific VLAN questions I can take offline or have one of our guys provide a better, more thorough answer on that.
I think what we'll do, I mean, as well, is once we're done, we'll run through as many questions here as we can, and maybe, I mean, I can get these offline as well, and maybe just,
we'll get everyone answered.
Kind of a detailed,
everyone answered, and they'll be distributed. Okay.
Okay, let's run through a few more here, as long as everybody's okay. Let's see here. The next question, specifically kind of talking about the core. When will the dollar a month plan begin? And where can I get the details? And I'm just going to say it's probably $1 US, everybody. Us Canadian folks are going to have to, pay the exchange rate. But and where can we get the details on that?
So that's, you can go to our website, and if you're hitting from a North American IP address, www.baicells.com will default over to the NA site, North American site. And if you go there and go through products, click on products, you'll see Cloud Core. In fact, if you don't mind, I can do that right here. So if you go here, Cloud Core, and it talks about it here. Then you can even begin to set up your account. I expect that to be activated probably about mid-February after we're completely through with testing. So this is part of the major set of upgrades that are happening right about now, where we've got the first 5 guys starting tomorrow that will be testing that. So the big part of that was trying to get the interface polished enough where we thought the utility was decent. But that's when that will begin. It hasn't as of yet. By the way, this is the same place you would go to find out the details of product registration. We have the Canadian stuff down, IC certifications down here. Okay.
Great.
Next.
This one kind of talks about, it looks like providers kind of migrating, probably from a WiMAX solution. So, they're seeing performance increases near twice the throughput and half latency versus WiMAX, which is, that's great. In simple terms, though, what is it about LTE that makes it better than WiMAX? And probably 802.16e WiMAX, I think we're talking about. But yeah.
Yeah, I think one, WiMAX only deals with 10 megahertz channels. Okay, that's a big one. So in LTE, we can do much varied channel sizes, including 20, right? So we can get a lot more capacity. The scheduler is a little bit better in LTE, and additionally, it's a standard that still survives. So the truth is, and I know the people that ran the WiMAX forum for the entirety of its life, the job of the guys closing it out were basically to slit their own throats, to end it, or migrate the standard on over to some vertical like utilities or something, or airports where it survives still to some extent. There's just no more money going in to WiMAX. So the fact is, it was a good standard. I was involved in WiMAX from day one. The problem was its overall market concept was a little bit utopian and I think frankly naive, trying to create this big, massive, all open environments, but the carriers like to define what devices ride on its networks. So without carrier adoption, it was ultimately not going to be successful. So LTE is at its relative beginning of its life cycle, and there's, like I said, over $1 billion a year R&D. So, that's really the most basic point. Technically, there was nothing wrong with WiMAX except for your limitation on channel size. And we all know we need bigger channels. So if you're running WiMAX now and you're successful in that, hey, you know what? Keep on going. But at some point, you will have to migrate. The key to doing that is the most important thing is trying to find shared TDD ratios that you could sync up, so in the transition you're not banging into each other and conflicting too much on your frequencies. That's the most basic important point as you transition.
Okay. I know we're running, we're over time here, but maybe if it's okay, we'll take one more question. Just looking, and I think this is actually a really excellent question. So, this person or this operator here is, asking, isn't it, they're thinking, maybe LTE, is a risky investment when they're looking at putting it into like a semi-licensed environment like 365. They're already experiencing issues with WiMAX products, and obviously, with interference and so on and so forth. So, what's the differentiator between, LTE and maybe some of the other solutions in the marketplace, and how in compensating for interference, how does it manage, with other subscribers, can they match GPS and uplink and downlink ratios? And I think we're kind of talking about the TDD frame, so that obviously they can sync up, other base stations, or maybe even with, other LTE solutions out there. Maybe if they do have an incumbent that's using LTE and stuff like that. I think the biggest thing is how does the base station handle interference and and so on and so forth. So.
Sorry, you'll hear my dog walking around, clickety clack on the floor. LTE doesn't inherently have a lot built in from the start to deal with the interference environment, right? As the standard evolves, you have things like coordinated multipoint and other techniques. They call it IC, which is basically an interference coordination sort of mechanism that I think is more marketing than actually effective. Coordinated multipoint maybe is ultimately one of the more effective technologies that'll be applied. But it hasn't been a significant challenge inside 3.x. In 5.x variants, yeah, it's going to be a big deal. And LTE, frankly, can take a big hit, especially in 5 gig. And if there's a lot of other 365 around where the environment isn't managed, it can be a challenge. It hasn't cost us a customer yet. Maybe one guy in Nebraska has decided that he doesn't have any trees, so any tower that's 150 foot hears everything for gazillions of miles around. But short of that, it's been manageable. In terms of other LTE, right? LTE is a standard, so there are common TDD ratios. As long as you're working in coordination with maybe adjacent operators and you can manage to share ratios, you should be able to sync to that. The same would be true of WiMAX. The standard made sure that WiMAX and LTE have a couple of shared TD ratios, so that can be helpful. A risky investment, I would say absolutely the opposite. Frankly, in my opinion, I think the risky investment right now, and I said this long before I was at even Baicells, I jumped on the LTE train because I think the risky investment is proprietary. There is no doubt, it's written on the wall, it's pretty much carved in stone, LTE will dominate the fixed space. So Part of that is because of this coming CBRS band in the U.S., the simple gravitational weight of what's going to happen there. Everything in that process is being driven and written around LTE. I think you're at a much greater risk by going proprietary because then you're beholden to a single vendor and its limited ability to R&D its way into solutions. LTE is at the beginning of its life cycle, and there's a lot of advancements that come down the line, and everything is backward compatible from a subscriber standpoint. Everything. Every forward revision, your subscriber doesn't have to be changed, unless, of course, you want all the new benefits of whatever the new feature set is, but at least you don't have to change out the subscribers every time a vendor decides it wants to do a new kind of product. Where that's been the big problem in proprietary, there's been a lot of really good vendors out there, but not a one of their products has been completely interoperable with their next generation of product. And I don't know how you guys sustain that on a CapEx model. This is much more simplified. Also, if you have an exit strategy, and everyone has an exit strategy, or should, the simple fact is most of your investors, consultants, they won't know how to spell proprietary, but they'll know how to spell LTE. And all your tenders are written around LTE. Your investors know it. The equity value of your network, I would contend, will be much higher LTE than it would be with anything else. It's a reason why all the bigger companies migrated to LTE, whether that's the big boys up there up north with you guys, ExploreNet, whether that's Rise Broadband down here and others. Everyone's moving to LTE because they know if they don't, they're in trouble. That's my position, and many might disagree, but that's where I stand.
Okay. No, that's we really appreciate your feedback and thoughts on that for sure. It's probably always on the back of everybody's mind, right? On obviously, making this investment and where would that lead me, kind of thing. So.
Well, you're not changing it. Right. Whatever these guys on this call are using right now, you're using principally to connect your line of sight customers, right? So you're not connecting your non-line of sight customers now, not in any kind of scale. So LTE gives you the opportunity to both unify your network under a standard that the rest of the globe is adopting, and by the way, connect a huge boatload of customers you can't connect now. So I don't see the negative, frankly.
Sure. Great.
Yeah.
Okay. Well, yeah, there's a few more questions here, but I think, just on, because of time and things like that, we'll take, again, we'll take them, all offline, even the ones that you have answered and kind of, get them into, into a written, kind of into a written format and get them out to all the attendees so that they can review them and even pass them along to colleagues and things like that. And, along with the recording of the webinar, which, we'll have available as well. So.
Well, thank you, and I appreciate it. And sometimes I might drone on certain aspects. So I apologize for that, but it's a pretty exciting space. I've loved it for the bulk of my career, and I'm really excited to be at a place now where I think we're creating an LTE solution that I think at least 80% of the market can adopt without fundamentally changing their business model. Right. So
for sure.
I appreciate the opportunity to talk to your folks.
Absolutely. No, thanks again, Patrick, for your time and obviously putting together this presentation and so on and so forth. And, and everybody that attended, thank you very much for taking the time. I know we ran a little bit over time, but, hope you found that it was, of value. Again, we'll be sending out a link, answer to, the questions that we've, collected and so on and so forth, very soon. And, I guess that's all we have for now. So thanks again, everyone, and have a wonderful day.